So let's continue on with 24.4 and 24.5, and we'll have some linear inequalities in two variables and nonlinear inequalities and systems of inequalities. So hopefully this is familiar also, solving a linear inequality in two variables. So we need two axes, an x-axis and a y-axis to represent this. So I find the easiest way of graphing the line that separates the true points from the false points is the intercept method, as long as the coefficient on x and the coefficient on y both divide evenly into the constant. So I set it up like this, where I say when x is 0, I can just see by mental math that y is -2. And when y is 0, I use mental math to see that x is 4. So 0, -2, and 4, 0 are points on the graph, and that's all you need to know where a line must go. But if you prefer solving for y and doing it with the slope-intercept, that's a perfectly acceptable way also. I just like this really efficient way when it works. So this particular inequality has a strict inequality. So that means you need a dashed line to represent that the points on the line are not solutions to the inequality. They're the points that would give you equals, and that's not part of the solution set because it's a strict inequality. So then there's two different ways you could proceed here. If you chose to solve the inequality for the y, you'd get -6y equals -3x plus 12. Then when you divide both sides by -6, you have to remember to reverse the inequality and get y is greater than 1/2 x minus 2. Well, if you get y is greater than, you know you shade above, but you need to indicate something to me that says, here's how I decided where to shade. I noticed that it was y greater than, so I shade above. So another more concrete way is to test a point that's on one side or the other. So let's test 0, 0 in the inequality. And we're asking the question, if we put 0, 0 in there, is the inequality true? And it is true. So you shade towards 0, 0. So you need to do one of these two things. Either show me that you notice y is greater than, and so that means above, or show me this test so I know how you decided where to shade. Okay, so that was one linear inequality. This is a system of inequalities. And so implied here is and so we want the overlap. So we want the intersection of these two sets. So we want to graph x minus y equals 4. So when y is 0, x is 4. And when x is 0, y is -4. And I have the or equals to, so I make a solid line to show that the points on the line are part of the solution set. And then I have x plus y equals 6. So when x is 0, y is 6, and when y is 0, x is 6. So I have my other line. Well, the first line, I would have -y greater than or equal to -x plus 4. Then if I divide by -1, the inequality reverses, and I get y is less than x minus 4. So I know I shade below this line. Or you can test 0, 0 and see that you get a false statement. So then for the other line, I have x plus y is less than or equal to 6. So y is less than or equal to -x plus 6, which is this second line. So I see I need to be below that line also. So the part that's shaded green and red, that's the solution set. I want to see all of your shading, and then I want you to emphasize for me which part is the solution set. So where it's double colored, that's the solution set. Okay, so now we have a non-linear inequality, so we're no longer drawing lines. And in fact, hopefully you recall and recognize this as a circle, where 16 is r squared, so the radius is 4. So when y is 0, x is plus or minus 4. When x is 0, y is plus or minus 4. And then I recognize the equation of a circle, and I have or equals to, so I have a solid line, the solid circle. Well, now I have to figure out what this means if x squared plus y squared is less than or equal to 16. Well, again, you can test a point because it's either all the points inside the circle or all the points outside the circle. The circle is the barrier between true and false. So if we test 0, 0, we can see this is true, so we want to shade towards 0, 0, or make sure your shading includes 0, 0, so you know it's all the part inside the circle. And you can use Desmos to check these also. It will graph these inequalities. Okay, then this is another inequality that's nonlinear because we have a squared term. So let's think about what y equals x squared minus 9 looks like. And here's where transformations can be really handy because this is the parent graph y equals x squared, which is your basic function parabola with the vertex at 0, 0. But then you have shifted it down 9. So you can see when x is 0, y is negative 9. And hopefully you can see that when y is 0, x is plus or minus 3. So we can draw our parabola. And in this case, it's a strict inequality, so it should be a dashed line. So it's hard for me to make dashed on here. Usually what I do is I draw a solid one and then erase bits. So I'm not very good at drawing dashed lines. Okay, then again we have to decide whether we want the points inside the parabola or outside the parabola. So let's test 0, 0 and see what we get. We're asking the question, is 0 less than negative 9? And it always helps me to put them on a number line. Oh, 0 is greater than negative 9. So this is false. So I want to shade where 0, 0 isn't. So I'm shading outside of the parabola. Okay, and then here's a system of nonlinear equations. So we're going to have a circle with radius 2. And it's dashed circle. And then 0, 0 is true, so I want to shade the interior of the circle. And now I want to know where I should graph y equals x squared. Oh, that is the parent graph parabola. And this is solid. And then let me test 0, 0. Oh, I can't test 0, 0 because it's a point on the parabola. So I need to test something like 4, 0 and see if that's true, because that will be obvious. So when x is 4 and y is 0, is this greater than or equal to 0? Definitely not. So I want the part inside the parabola, but I only want the part that's colored with the red and the blue, so the intersection of those two sets. And that's the solution set. So that's it for the 24s.